Hello, welcome back to the channel. So let's continue our previous video and solve this improper integral over here using all the concepts that we covered in the last video. So if you have not watched my previous video where we have covered these concepts in detail on how to solve such type of integrals, I'll highly suggest you to first watch that video in order to get the full context of this video. So now we know that we have to evaluate the integral of 1 upon 1 plus x squared dx, right? And we know that if we want to calculate the indefinite integral of this expression, this indefinite integral will basically be tan inverse x plus c, right? But since in this case, since one of the endpoints is not a real number, we will have to use the methods to calculate improper integrals. And you can clearly see that this matches with this pattern. You can clearly notice that 1 upon 1 plus x square is defined for all real numbers. The domain of this function is all real numbers, right? Because you know that x square plus 1 cannot be 0, so the denominator cannot be 0, which means that this function is defined for all real values of x, right? So we know that the limit from x equals a to x equals capital R for any real number capital R greater than a, which is basically any real number greater than small a in this case for this function. Since we already know that the domain of this function is all real numbers, so it clearly satisfies this condition over here, right? And now in order to solve this integral, we know that we'll basically calculate the definite integral from x equals a to x equals capital R, which will be an easier process because we will just have to plug in the endpoints in order to calculate the definite integral. And then after we are done with this calculation, we will take the limit of capital R approaches to infinity in order to find the final solution. So let's do that. Now our main question is calculating the integral from a to infinity of 1 upon 1 plus x square dx, right? And again, in order to solve this integral, what we'll have to do is we'll take limit capital R approaches to infinity of the same integral from x equals a to x equals R. And you know that this integral is basically arctan x. So we'll take limit R approaches to infinity. This is arctan x. And the limits are basically a and r. And we know that this limit will remain the same. And this inner expression will be basically arctan, or if you're familiar with tan inverse, it will basically be tan inverse capital R minus tan inverse small a, right? And now we can proceed on taking the limit. We know that if we take the limit of R approaches to infinity for this expression, we'll have to plug in the value of R as infinity. And we know that tan inverse infinity is basically pi by 2, right? So if we solve this expression, this is basically calculating pi by 2 minus tan inverse a, right? Because the second expression doesn't change since it does not have a capital R in it. So now this answer will be the final answer to your definite integral over here. So you noticed how easy it is to calculate such type of integrals when you know the concepts in order to simplify these integrals into this form and then taking the limit calculations in order to calculate the final answer. But there is also one more important point that we'll cover in the next videos. Sometimes you'll notice that when you'll take the limit at the last, the limits for these inner expressions won't always exist, which is also a possible scenario. In this question, the limit existed because we were able to calculate the limit of this expression and we got the final answer as some real number. But note that it will not always be the case that your limits will exist at the end. So that's it for this video. Again, the main takeaway from this video is to know the concepts that you use in order to solve such type of integrals. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.